What is an arc flash? If there's an electric fault and there's enough energy behind it, it can ionize the air and create this massive and explosive event that we call an arc flash. Most of the time we're concerned about these in three-phase systems, but it creates blinding light, it creates intense pressure and sound waves, loud enough to be deafening or possibly fling shrapnel around or throw you across the room. It creates an intense amount of heat. Even though they happen in a fraction of a second, they can reach thousands, if not tens of thousands of degrees, instantly vaporizing the material right where that arc core is, where the flash is actually started, and it could melt material as well, making burn injuries incredibly dangerous and prevalent if you're not prepared for that arc flash to happen. But what is an arc flash study? A lot of times people call them arc flash hazard analysis or a risk assessment of some form. Essentially, it's looking at the electrical distribution system and determining, well, how severe would an arc flash be if it were to happen? Utilizing the results of the study and the severity, typically calculated in incident energy, calories per centimeter squared, we can provide guidance on what PPE to use, how far those boundaries are, and how far away other people need to stay to avoid getting hurt from those hazards, as well as some engineering controls, simple methods like adjusting settings or replacing fuse types to lower that potential severity of an arc flash. So why do you need to conduct an arc flash study? Well, there's three main reasons. The first one being for risk assessment purposes, second, hazard mitigation purposes, and of course, to comply with regulatory codes and standards. But let's look at each of these. For the risk assessment process, you have to know the severity of the potential hazard you face in order to implement the correct controls. Without an arc flash study, you simply are left in the dark as far as how severe an arc flash might be. Any reputable supplier of an arc flash study will help with the second item as well, hazard mitigation, giving you tools and methods to help lower that potential arc flash severity, the calories per centimeter squared, trying to lower that to the minimum possible given your system requirements so that there's less risk in turn. And then the third one being regulatory codes and standards compliance, because NFPA 7D, OSHA, and local regulatory bodies are all clear. Workers have to be protected against recognized hazards in the workplace. Electric shock and arc flash both being very prevalent in any industry. But when should you perform an arc flash study? Anytime you have newly installed equipment, you're going to be left wondering, well, what is the severity until you have an arc flash study completed? The initial startup for new installations is often a problem, especially if there's been any shortcuts or poor performance in work. You don't know that until it's turned on a lot of times, unless you have a really rigorous inspection process. The other time is if you have modified equipment. You've changed something that seems pretty simple, like you've adjusted the settings on your breakers or your relays, or you've changed out fuses to a different model, but it's the same amperage rating, so it should be fine, right? No, that can drastically change the results of the study. Any system modifications, even increase in the wire size, the conductor size because of voltage drop issues, for example, that impacts the results of the study. All those elements are included in the calculations, and that should prompt you to redo that portion of the analysis. At a bare minimum, you should be getting your study reviewed and updated every 5 years per the NFPA 70E. But that's a bare minimum. In reality, things happen and change way more often than that, prompting you to get that study reviewed and updated sooner. What are the requirements for performing an arc flash study? Well, we need detailed information about what's actually installed in your electrical system and how it's all installed together. We start by looking at that utility contribution. How much available fault current is present at your facility? That impacts how fast each device will operate throughout the rest of your system. So we need accurate information from the very get-go. But then what else? Once we get into your facility, we would need to look at all your breakers and fuses and wire types and sizes and how many conductors are per phase and what transformers there are, their sizes and impedance, the types of motors and how large they are, if you have any VFDs or soft starts. All this information is vital to having an accurate and complete system analysis. Otherwise, you may or may not actually have a correct arc flash label applied to your equipment. Take out as much guesswork or assumption as possible whenever you're talking about life and death topics like an arc flash hazard analysis. Who can perform an arc flash study? This is such an important question because there are a lot of studies out there that I highly question the results, and those labels might be drastically misleading workers on what is needed for their protection. Typically, these are considered engineering studies and require a licensed electrical engineer to perform and/or review that analysis before it's implemented into your workplace. Again, this is life and death stuff we're talking about. If someone is not properly prepared, they could be in the hospital for months on end, or worse, it could end in a fatality. Taking these arc flash studies seriously and having someone who is truly proven to be qualified performing these studies is vital. That way you can know the equipment you're putting on your workers, the boundaries you establish before work, the hazard mitigation techniques and selective coordination, and other risk controls that are recommended as part of that study can be trusted, and ensure that your workplace is as safe as possible regarding these arc flash hazards.